Today I'm going to be showing you 5 ways to solve the area of a triangle. The first one you probably know and probably should know is that the area is equal to 1/2 base times height, or in this case 1/2 times A times H. This one you definitely should know. Next to the fact that the height is equal to sine C, this angle over here, times H is equal to sine C times H, it makes it so that the formula is true. The area equals 1/2 AB times sine C. There's our second formula. Next is a formula you should know if you want to find the area of a triangle when you only know the 3 sides. First of all, we have to look at the formula that we just made. This one over here. This formula already has 2 side lengths, AB here, but we don't know the angle C, so we need to make it so that sine C is represented in a form which makes it so that its sides represented of the side of the triangle, ABC. Well, since the cosine of C is equal to A squared plus B squared minus C squared divided by 2AB because of the law of cosines, we can use that. But this is for cosine, not sine. So to convert cosine to sine, we have to there's this formula over here, which is also known as the Pythagorean identity because it comes from the Pythagorean theorem. This formula states that sine C is equal to 1 minus cosine squared C. Put cosine C into here, then you'll get this equation over here. Now just put that equation into equation 2 here, and then you'll get this. Next is all just algebra, and you really don't need to know any. There's not really anything important here, except for the fact that here we can use the fact that this is, if we let 2AB equals x squared, it'll be 1/16 times x squared minus y squared if we let a squared plus b squared minus c squared equal y. Now this should look familiar because you can make this into y plus x times x minus y. So that's what we did over here to avoid confusion. Something else that you should take away from this is the fact that in this expression goes into these 2 expressions over here, and this one over here goes into these 2 over here. And then S is A plus B plus C divided by 2, also known as the semi-perimeter. That's why it's called S. So by putting that into here, you get the third formula, Heron's formula. The area of a triangle is equal to S times S minus A times S minus B times S minus C. Here are the next 2 formulas. Here there's a triangle, and where it has an inscribed circle over here. Oops. The area of this circle is equal to 1/2 times A times R plus 1/2 times B times R plus 1/2 times C times R. Why is that? Well, when you separate this triangle into 3 different triangles, not 4. Whoops. Then you can see that this is true. 1, 2, and 3. Since we can use the first formula over here to prove it, since these 3 triangles have a base of A, B, C, sorry, I forgot to write that, and have a height of R for each, that means that we can add all together to find the area of the total triangle, leaving us with this equation over here. So this equation equals 2, by taking r and 1/2 out, you get r divided by 2 times a plus b plus c. This can also equal to r divided by 2, whoops, not r divided by 2, sorry, r times s. S is the semi-perimeter, which we find out over here. The next formula involves a circumscribed circle. Here we know that the sine c is equal to c divided by 2r, because we know that 2r equals to c divided by sine c. We can prove this by the red or green triangle, and I'm going to be explaining both. In the green triangle, in the red triangle over here, it has a hypotenuse of AD, which is 2r. And this is a perpendicular angle since, well, this is the diameter of the circle. Because we know that this is 2r and this is side C, and I definitely forgot to write that again. Whoops, sorry. This is C, A, no, not B. This is B and A, sorry. Since we know side C and side AD, the sine of C, that means sine D over here, sine ADB is equal to C divided by sine C. Well, to prove this angle is equal to angle ACB over here, well, that's pretty easy because they have the same arc and they're both inscribed circles. Next, we can prove this again by using the green triangle over here. This triangle again is a right triangle since it goes down to here, which this triangle over here is an isosceles triangle, making it perpendicular. Since this is 1/2 c divided by 2, and this we know is r, we can, we know that sine EOB over here is equal to c divided by 2 divided by r, which is also equal to c divided by 2r. To prove that this angle is equal to angle ACB, well, this is half the central angle AOB, which shares the same arc as ACB. Since an inscribed angle was the same arc as a central angle is half of it, this means that these two angles are the same. Now, if we put this into equation 2, which is over here, formula 2, I should say, we'll get, the area is equal to 1/2 times, that's 1/3, 1/2 times AB times C divided by 2R, which is also equal to ABC divided by 4R. And there you go. Those are 5 formulas, or 6 if you count this as a formula, but not really, to find the area of a triangle.